Hi, and welcome to freenetworkstudy.com. In this security lab, we will be configuring an Ipsec VPN between two 3725 Cisco routers. Looking at the diagram, we see two routers, router 2 and router 3. On router 3, loopback interface 0 will emulate the headquarters LAN, which is running on the IP subnet 1.1.1.0/24. On the remote end, the R&D LAN is emulated by interface loopback 0 on router 2. Finally, router 1 is emulating the internet and has no route to 1.1.1.0/24 or 2.2.2.0/24. The requirements for this lab are pretty straightforward. We will configure an IPsec tunnel between the R&D site and the headquarters. So let's get started. On router 3, let's look at the state of the interfaces. Show IP interface brief, and they're all up. Let's look at the routes. Show IP route. Okay, so we see the connected route and the default route to the internet. Let's quickly do the same thing on router 2. Show IP interface brief, and they're up. Show IP route, and we do have the default route to the internet. Let's jump back to router 3. Before we get started, let's see if we have IP connectivity. Ping 2.2.2.2, and the ping is failing. That's because router 1, emulating the internet, doesn't have any route configured. That's very realistic, since the real internet wouldn't have any route to your private networks. Great, let's configure that IPsec tunnel. We'll start by telling the router which traffic is to be protected. We'll do that with an access list. Here I'll use an extended access list, IP access list extended, and I'll call it L to L, short for LAN to LAN. Now matching the traffic to be protected, permit IP, and the local LAN is 2.2.2.0/24. The remote LAN is 1.1.1.0/24. Now step 2, we have to tell the router how to protect the traffic. And we do that by listing all the security protocols to be used in a transform set. Crypto IPsec transform set, and you can give it a name. I like to name my transform set by listing all the protocols that are being used. So I'll call it ESP-AES256 and SHA. Now we have to list the protocols to be used for the IPsec security associations. So as the name states, ESP-AES 256 bits, ESP SHA and MAC. Step 3, we have to define the IKE policy attributes. We do that with the crypto ISACamp policy, and in policy configuration mode, we list all the attributes. So encryption, we said that was AES 256 bits. We told to use a pre-shared key, Cisco, and we define that attribute with the authentication, pre-shared. Next, we define the diffie element group to be used, group 5. Now exiting the IKE configuration mode and defining the peer attributes. Crypto ISACamp, here we enter the pre-shared key, Cisco, the address of the remote end. Oh, I forgot to tell if the key was encrypted. So we do that here with a 0 if it's unencrypted and a 6 if it's encrypted. In our case, it's clear text. So 0, Cisco. Now the address of the remote peer, and that was 10.0.112.2. You can also define the keep alive timer to make the tunnel more reactive to change. Crypto keep alive ISACamp keep alive and 10. Alright, so now we can bind everything we just did with the crypto map. Crypto map, the name of the crypto map, CMAP for crypto map, the sequence number 10, and the protocol IPsec ISACamp. Now when you see that message here, don't be alarmed. It's actually great help since it tells you not to forget the matching access list at the end. Next, add the PR address. That's the address of the remote gateway. That was 10.0.112.2. Tell the router which transform set you want to use for this crypto map. That would be the only transform set we defined so far. Set transform set, and the name was ESP AES 256 SHA. And finally tell the router which subnets are to be protected. And we do that with the match address and the name of the access list, matching the traffic to be protected, L to L. So the last thing we have to do is apply that crypto map to the interface connecting to the internet. And that is interface, let's get out of here, interface fast Ethernet 0/0. We simply type crypto map and the name of our crypto map, CMAP. Great, so that's it for router 3. Let's jump to router 2 and do the same thing. Only this time we can do it faster since it's the same process. Conf-t, start with the access list, IP access list, extended L2L, permit IP, this time is 1.1.1.1.0/24, and the remote end is 2.2.2.0/24. We'll create the transform set, crypto, Ipsec transform set, ESP AES 256 SHA, ESP AES 256 ESP SHA HMAC. Now defining the IKE policy, crypto Ipsec policy 10, encryption was EAS 256, authentication was pre-shared key, and the Diffie Hellman group 5. Crypto Ipsec key 0 Cisco, and the address of the remote gateway is 10.0.13.3, and the keep alive was 10. Now let's bind everything in the crypto map. Crypto map, call it CMAP 10 IPsec Ipsec. The remote gateway was 10.0.13.3. The local transform set was ESP AES 256 SHA, and the access list match address L2L. Okay, let's apply that crypto map to our outside interface and check our configuration. So interface fastnet 0/0 crypto map CMAP. Okay, let's jump back to router 3. On router 3, let's look at the security associations. Show crypto Ipsec security association SR. Okay, so the security association table is empty, and that's because no traffic has been sent on the tunnel. Let's send some traffic. Ping 2.2.2.2. This time we're pinging the remote LAN and not the gateway. Let's try it just like that, and it will fail. I'll explain why. Okay, it's failing, and the reason why is that router 3 is trying to ping the private subnet on the R&D department, but sourcing the ping from its outside interface, and that source address is not part of the protected subnet matched by the access list we defined. So a better test would be to source the ping from subnet 1.1.1.0/24, and our loopback interface 0 is precisely on that subnet. So let's source the ping from loopback 0. Source loopback 0. Okay. Okay, let's have a look at the security associations. And why is that? Show IP access list. Okay, I think I know. Show IP interface brief. Ah, okay, okay. Classic mistake. I just inverse the access list. That's why my ping is not considered by the crypto map. Let's just fix that real quick. Conft no IP access list extended L12. Was permit IP, and this time from 1.1.1.0/24 2.2.2.0/24. Okay, we have to do the same thing on R2. No conft no IP access list extended L12. Permit IP 2.2.2.0/24 to 1.1.1.0/24. Alright, let's try that again. And this time it's working. Let's have a look at the security associations. Show crypto ISACamp SA for security associations. And now we see the security association created between our local gateway and the remote gateway. And that was it. Thank you for watching.